Hey everyone, welcome to Morning Space Lab. In this video, I'm going to introduce a very interesting lab project called Lab Kubernetes and tell you how to use this project to launch a multi-node Kubernetes cluster on your local machine in less than 1 minute. To quickly deploy and launch Kubernetes cluster on a local machine or a continuous integration environment is very useful. There are many different ways to do that. For example, we can use Minikube or Docker Desktop, which has integrated Kubernetes since its version 18.06. This makes it really convenient. However, currently they only support single-node cluster. Single-node cluster has its own limitation. For example, it cannot work with scheduler-related tasks or run tests that require multiple nodes. Another disadvantage for some of these approaches is that you may not be able to specify a particular version of Kubernetes very easy. For example, my Docker desktop uses Kubernetes 1.10. If you want to try some new features that are only available in newer version or the latest version, you may have to seek for other approaches. In this video, I will introduce a great tool called kubeadm Dyn cluster that can deploy multiple node cluster on a single machine based on kubeadm and Docker in Docker technology. Instead of using bare metal or virtual machine, kubeadm Dyn cluster uses Docker container to run cluster node. With that, all nodes can be deployed and run as containers on a single machine, and application containers that previously run on Kubernetes nodes will in turn run in these containerized nodes. That's where Docker in Docker comes into play, or we call it Dyn. This is because it allows one Docker container to run in another Docker container. By using kubeadm Dyn cluster, it allows you to switch among different Kubernetes versions very easily, and even you can use the latest Kubernetes snapshot by building from source. Moreover, to optimize the use of kubeadm Dyn cluster and make the bootstrap of the cluster more efficient, I created a demo project called Lab Kubernetes. It is based on kubeadm Dyn cluster with some additional optimizations that I will introduce later in this video. At the end of this video, you will see that we can launch a 3-node Kubernetes cluster in less than 1 minute, even without network connection. It is easy to launch Kubernetes using kubeadm Dyn cluster. You can just follow its README to download the pre-configured script, then run it. For example, currently the latest version of the script is Dyn cluster version 1.13, which maps to the Kubernetes version 1.13. You can run Dyn cluster version 1.13 to list all available commands. And then run up command to launch the cluster. It'll take a bit longer for the first launch because it requires to pull images and download dependencies from public network. Any other launch after that will be much faster because it'll create a snapshot locally after its first run so that can restore from that snapshot very quickly at any time later. When the launch is finished, by default, it'll bring up a 3-node cluster, 1 master node, and 2 workers nodes. This is configurable. If you want to take down the cluster for some reason, use down command and this will keep the snapshot, so that can restore from the snapshot next time when you run up command again. For a clean launch without using snapshot, run clean instead. This will remove the snapshot. To speed up the launch, the first optimization that I like to introduce is to use private Docker registry. So to restart from snapshot makes Kubernetes launch fast. It can be much faster for clean start if we use private Docker registries. As I mentioned earlier, Kubernetes Dyn cluster pulls images from public Docker registries such as Google Container Registry and Docker Hub during the launch. If we copy these images to a private Docker registry that is co-located with the Kubernetes cluster on the same machine or in the same local network, and have the cluster pull images from there, it'll make the bootstrap dramatically faster. This has been added into the project Lab Kubernetes. Where you can find all private Docker registries configured in dockercompose.yaml file. Each registry itself is also a container that can be launched by Docker on the same machine where our Kubernetes cluster runs. All registries have a shared volume to store the images and a shared bridge network to communicate with the cluster. If you are interested in how to import upstream images from public Docker registries to a local private registry, please check my other videos regarding the use of Docker Registry CRI. After the private registries are populated, we can launch them by simply running the docker compose command. Then we can run Dyn cluster wrapper shell script in the project lab Kubernetes to launch the Kubernetes cluster. This shell script is actually a simple wrapper of Dyn cluster shell script. Since it's just a wrapper, we can use the same set of commands as you do when run the Dyn cluster shell script. For example, to run up, down, or clean command. The wrapper will download the specific version of Dyn cluster shell script from its GitHub repository to the current folder on your local machine if it does not exist. You can use the environment variable Dyn Kubernetes version to specify the Kubernetes version, or use the latest version as the default value. Before run the shell script, we need to configure Kubernetes Dyn cluster to recognize the network shared by the Docker registries so that Kubernetes can pull images from there. Also, if the registries are not TLS enabled, we need to let Kubernetes Dyn cluster know. These can be done by exporting these two environment variables. Since we now use private registries to pull image and it runs on the same machine, we can even cut off the network connection during the Kubernetes cluster launch. The only thing that you need to do prior to that is to set the environment variable called Dyn skip pull to 1. The Kubernetes Dyn cluster itself has an image that is required when launched the cluster. It is pulled from Docker Hub, but it doesn't have to be pulled all the time if we have it cached at local after its first launch. This flag tells the shell script not to connect to the Docker Hub and try to detect and download the image. With that, we can cut off our network connection and see the bootstrap still runs perfect. Okay, that's all for this video. Thanks for watching. I hope that you find this video useful, and if you did, please share it. I would appreciate it. This is Morning Space Lab. See you next time.